Just an overview of the talk. So kind of three parts. First, I'm going to talk generally about what machine learning and deep learning are. Second part, I'll talk about some fashion applications of machine learning. And the third part, I'm going to talk about work that we've done at FTSY using computer vision and machine learning. So hopefully there'll be lots of time for questions at the end. Should go for about 30 minutes, me talking. So first of all, what is machine learning? So you might have heard other terms, computer vision, AI, pattern recognition, data science, all these things. They're kind of not being used very strictly these days, and I think big data and data science were popular a few years ago. Now AI is popular, but machine learning's there throughout, probably less well-known term. Basically, it means that you're teaching a computer to do recognize things by example, and kind of, forming tasks that a human traditionally would have, because it requires some kind of, recognition or intelligence. So there's two classical machine learning tasks that you would find in a textbook: classification and regression. So in classification, you have some data and then you want to categorize it automatically. So in that example there, got, there might be some customer review data, and you put it through your black box and it tells you whether that review was positive, negative, or neutral. So you have to predefine all that stuff, the categories and everything. Regression is a bit like that, but the output can be a continuous value, like a temperature or something. So, for example, you might have some market campaign data and you want to do regression to predict the conversion rate based on that. And then there are other problems: detection, segmentation, tracking, that are all related, but they're the kind of core things. So machine learning, is a big area, sort of multidisciplinary in academia. You get people from maths, physics, engineering, computer science, cognitive science, psychology, but lately it's been dominated by artificial neural networks or deep learning, deep neural networks that you might have heard about. So that's mainly what I'm going to talk about here. So this is what a neural network looks like. It's meant to be a mathematical model that's kind of loosely inspired by biology, by the way, our neurons work in our brains, but it's very loose. But the idea is that the network is in layers like this. You have an input layer, and then data goes in there, and then there's weighted summing and some non-linearity, and then that becomes now the input to the next layer, and then you have some output, like your classification outputs. So that's your simple kind of 1980s, 1990s neural network. And then the thing with deep neural networks is that you have a lot of layers. So what's happened recently is working out how to train those deep networks. So that's sort of very high level. This will be a high level talk. But qualitatively, what's going on in deep learning? Well, there's a type of deep neural network called a convolutional neural network. That is an example of the kind of feature maps that they generate, or filters that they generate. And the idea is that as you go deeper in the layers in the network, the network is learning features that are more and more abstract. So, for example, we start here with like little edges or blobs, and then group together into maybe corners or, these ring-like structures. And then you start to get parts of things, like parts of wheels and that, and parts of faces. So this is going from the low layers up to the high layers. So this is an example where someone tried to work out what's going on in the neural network. Oh, that's loud. So it's hierarchical. Well, what you hope is that the network is learning some sort of hierarchical set of features that are more and more abstract as they go along. That's what people believe happens, but it's really a black box, and it could learn to solve the problem in any way. So how did we get where we are now, where people are banding about the word deep learning and using it a lot? So neural networks were popular like in the 80s and 90s, and then they sort of fell out of favor for a long time. In about 2012, one of Jeff Hinton's students, Alex Krzyzewski, did this experiment or entry in this ImageNet challenge where you have 1,000,000 images and you've got to categorize each image as being belonging to one of 1,000 classes, maybe a breed of dog or a bottle of wine or something like that. And he used graphics cards in his bedroom to train a neural network like this, I think for his PhD, and he got, a much higher accuracy than anyone had got before on that challenge. And people took notice, and next year, every entry in that competition was using these deep convolutional neural networks, and then it just exploded from there. So what happened next is people realized that actually when you train these deep neural networks on different data sets, you get like some similar features, and that, trained on every single image that ever existed, would that just be the ultimate set of features that you need to do any sort of recognition? So what people realize is that you can use these learned features or networks as sort of reusable features for different problems, which is called transfer learning. And this was a famous paper where someone took those ImageNet, AlexNet trained network, took the features and all these different benchmark problems that were public problems. They just used those features to solve all those problems, and they got as good as or better than state of the art on all those problems using one method. Whereas, the comparison is, you do something like this that's complicated and it's different for every problem, and it's the sort of thing that you spend 3 years doing a PhD on. So lots of people's PhDs kind of got made redundant overnight, although it's still, all instructive. But that's why, industry has really sat up, taken notice of deep learning. And you've got, NVIDIA's loving it, and Google and Facebook and all those companies are investing heavily in it. So now I'll talk about, some examples of how deep learning is used. So this is the ImageNet challenge that started it off. You have images, and although there can be lots of things in the image, it's a little bit ill-posed, but you just say, there's just one correct label to say what's in the image, and you want your classifier to predict it. Sometimes, they give the top 5 answers and calculate a score based on that. But you can see that, it's uncontrolled. You might only see part of the object, and it could be obscured by something. Detection, which is a harder problem. You want to draw a box around every object in the scene and say what it is. And this has progressed as well to also give masks for those objects. Semantic labeling or segmentation or semantic segmentation means you want to classify every pixel in the image. So then you group into regions. So like this indoor scene, you've got all the bed pixels in green, the window pixels in purple. It's very popular for street scenes because of autonomous driving, having a car knowing where everything is. And also, this is a LiDAR example, like a 3D point cloud from a laser scanner. You can do segmentation on that as well. This is an example of work I did in a previous job, where you have satellite images and then segment those satellite images into different regions like roads and buildings and trees. You can see you can get a pretty good level of detail as well. So just to make it clear, the input is that, and the output is that in the neural network. So people have realized, you can do all sorts of crazy things with these models, and there's been a lot of imagination and creativity that's in recent years that's gone into just how to use it. And every day, if you look on Mashable and LinkedIn and things, you'll see all these amazing examples of things that have been done. One popular problem is image captioning and visual question answering. So here, the input is the image, and the output is this text that you can use, type a neural network called a recurrent neural network to generate text. So, it said here, man in a black shirt is playing guitar. And so these are automatically generated by the neural network. It's deep learning has been used in art as well. So once you have one of these networks, like AlexNet or ResNet, you can try to generate an image from that. That's kind of just seeing what the features generate, and these are kind of there's no input. It's like trying to that's why they call it deep dream. It's like the neural network is dreaming. You're trying to see what it can come up with. You get these crazy landscapes. So that's all automatically generated. You can also apply it to an image and texture an image. So you might have seen apps on your phone that do this kind of thing. Style transfer is an interesting one, maybe for fashion as well. So you can take a painting, learn the features of the style of that painting, and then apply it to a photograph, and then that's the output. This is the input, that's the output. Some more examples there. This is a photograph, and then there's 3 different styles have been applied to the same photograph. And you can get apps on your phone that do this if you want to try it out. Something more recent that's really impressive in terms of how people are just pushing what you can do with deep learning is, we looked at segmentation, for example. The input is an image and the output is all those masks. What if you go backwards? You start with the mask and generate the image. So here's a video, and I'll just skip to certain bits of it. But yeah, that's kind of showing you, that's the input, and then that's the output. So that video is automatically generated by the neural network. It's like a synthetic image. So if you look here, you can see that the texture does look quite weird, like they don't look like real trees. But yeah, pretty amazing that you generate stuff like that. And I think one of the features of this work is that it's high resolution imagery as well. So here, they've just used the boundaries of faces to generate those facial images. So they're not real people, they're automatically generated, synthetically generated people. But of course, this is very high quality. So here's an example where that's the input, and then you can generate 3 different kinds of output with some extra randomized inputs. The kind of 3 alternative people that corresponding to that. And also apply it to dancing. So this is the synthetic output, and this is the input, the animation. See, there's all sorts of cool applications there. There's an example here where they changed the classes. So here they've changed the trees to buildings by changing the color of that to that. So the label of the trees, the building label. So every pixel's just got a number saying, 1 is buildings, 2 is tree. So you just change a whole region and it'll automatically change it. So yeah, it's seen here as a kind of a video editing tool. This is all the sort of stuff that is, this year's conferences. So it's bleeding edge. It's going to take a bit of work to apply it, to deploy it. Yeah, the question was how long does it take to generate the frame? So you need to use GPUs, like graphics cards. So I don't know for that specific example. It might not be real time, but it would be close to it if it isn't. Yeah. And you can imagine you could probably throw more GPUs at it, if you want to. But maybe soon it would be real time. That's the same one. Did I skip a slide? Yeah, something interesting for fashion as well as knowing where people are in the scene. So pose estimation or human body pose estimation traditionally has been, this kind of thing where you draw a skeleton on somebody, which is good. But in this work, they actually have a morphable model of a human body that's been fitted. So that means, if you're skinny, the model will look skinnier. So on. There's had some good examples. It was kind of impressive, the results. The poses were quite, you know, could be quite unusual, and it was still able to fit to the person. There's a bit where they do parkour. It's cool. I'll try and find it. Yeah, so just to be clear, that's the input, and then the output is this silver man that's superimposed. So you can see there's some quite challenging poses, and it's tracking okay.